Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z, and welcome back, some of our live viewers. I know it's been a little while since we've been live, but we're going to resume as we were before until the Christmas break with weekly podcasts. So should be back to normal though. One thing we have been kind of thinking about, and do want some thoughts, especially from the live viewers on, is us possibly moving to a record like VOD only format for the podcast. And the thinking for that is just uh, make make it a little bit easier on us so that we don't have to have a fixed time that we always go every week. And then also we could do some more like touch ups and editing on the recordings. Some who watched the last podcast that we did might have noticed that some of the dead silences that we had sometimes were cut out and whatnot. So that's the kind of editing that I'm talking about. We're not sure if we're gonna go that route after the new year or not. So we're curious to hear what your guys' thoughts are on it. So feel free to leave them in the Twitch chat or in the Discord or whichever. So yeah, we'd appreciate some feedback on that. But yeah, that's some of the housekeeping stuff out of the way, and we're gonna jump into our topics. So we're gonna start off with a little bit of a like drama type story. We're a little bit late to this because it actually happened like over the last few weeks. It came out of Pwn to Own, which we're not really going to cover because Pwn to Own is mostly like IoT type targets, like this one. Although this one's kind of notable because it touches on something we've talked about with Pwn to Own before. So this is from I'm going to say Wyze. I'm not sure if that's how you're supposed to say it, but that's the name of this camera company. And they have the Wyze Cam V3, and that was one of the targets that was eligible in Pwn to Own. So what had happened here was there was a researcher. He goes by the handle of Blasty. I think we've covered some stuff from him before. He does some pretty cool work, and so he put out a GitHub um, post. Sorry, I'm just gonna try to get that up on the stream here really quick. I thought I had it up, but I did not. So yeah, he posted a GitHub repo and basically publicly disclosed a few vulnerabilities in the exploit chain in Wisecam v3. And the reason he did this was because he was intending to take this exploit chain to Pwn to Own, and then like a day or two before the event, Wyze had shipped a patch that had shipped the entry point. So I won't go into the bugs too much here, but they are like the technical information is on the README if you want to check them out. The one that I think is critical here is the DTLS authentication bypass. So there's a Stack Overflow in JSON unpacking, but in order to reach that, you would have to like establish a session with Wyze. And yeah, there was just this auth bypass where they had sort of a fallback. Yeah, there was a fallback method, and you could just specify like your own identity using this auth token prefix and pick an arbitrarily chosen key to get in a session. So nothing too interesting, but that was critical to exploiting the chain. There were some other researchers who submitted in Pwn that got bit by this too, apparently.
So just before
This patch.
you carry on, sorry, did you open up a link there? Because nothing popped up on the screen for us.
Yeah, I did. Sorry.
I
Is this
guess
still
I'm
not
just
showing
not
up?
getting your event. Do you want to send me the link on Mumble and I'll just open it?
Yeah, yeah. That's weird that it's not going through though. Uh, so yeah, you can just scroll down to the bugs section, and it'll show that. But yeah, so that auth bypasses the thing that got fixed. Blasty wasn't super happy, so he decided to publish the exploit chain, and the vendor, in turn, Wyze, they had posted a thread, and it started a bit of a drama because they were like, unfortunately, this researcher had to back into the composition because the firmware update addressed this planned demonstration. This person then disclosed details about the vulnerability to the public before we had concluded all of our updates. Uh, and basically, the thread was a bunch of people dogpiling on Blasty for choosing to release the exploit and vulnerability details before everything might have been patched. Because another thing here is, while this bug affected the Wisecam v3, it also seems to have affected other products in the stack. But Wyze had only shipped the patch for the v3. They hadn't shipped it for like the Pro or any of the other products, which was also kind of weird. It made it seem like they wanted to very quickly, patch a bug right before Pwn to Own, only on the target that was eligible for Pwn to Own, to kind of, kill any exploit chains that might have been targeting them, which we've talked about with Pwn to Own before. Like, it is kind of it's sort of a common occurrence where vendors will ship updates like the day some I think it used to be they'd ship it like the day of, and then Pwn2Own had put a rule in place where it's like, okay, you can only like it's going to be based on the version from the day before or something like that. I forget the specifics. But yeah, like vendors shipping patches around Pwn2Own is nothing super new. And even if it doesn't patch a particular bug that you might be using, it might change the code just enough to break your exploit and make it so that you have to do a bunch of work to fix it, or that you just can't fix it in the given time frame. So it's always been a bit of a struggle between the researchers and the vendors on that aspect. But this case is a little bit like interesting because of the like public facing um, back and forth between the researcher and the vendor. So a lot of people in this thread I don't really agree with. There were people in this thread calling for like Blasty's job, saying like he should never have a a career in infosec or something, which is just insane.
So I also
Um,
don't have the Twitter if you're looking at it, if you want to share that link.
oh, so what I'm talking about here is from the Wyze forum thread.
Oh, right in here.
Um, yeah,
Okay.
in the first link. So yeah, there's people in there calling for all sorts of things. It's kind of crazy. I'm not going to go too much into that because I think that that's just dumb. It's not even like he like O'Day dropped them or anything like that. Like it was patched on the target that Wyze had put out, and that was the whole reason he put the repo up. Um,
Well, so
but
it sounds to me like it was patched on one target, but
yes, on the
not
target that was
on,
in Pwn2Own.
yeah, but not on all of them. So he was dropping something that was a vulnerability elsewhere, just not on that one target.
Yeah. So I feel like I have some thoughts on both sides here. So from Wise's side, what their argument was they weren't trying to patch it right before Pwn2Own. They were just quick to patch an issue that was reported to them, and it was reported like pretty close to Pwn2Own. Like they show the screenshot of a report. It's redacted, like the title and everything is blacked out. But on the 18th of October, there was an auth bypass and RC from LAN submitted. So their argument was we were just quick to patch it. We knew it affected the Wisecam v3 because that was in the report, and we decided to patch it there and then wait and investigate to see if it affected other products in the stack before shipping patches to those. Um, for me, that seems a little bit unlikely because, for one thing, it seems kind of weird to patch it prematurely for like one product before investigating if it affects other products, because attackers will patch diff. Like it's known that that's a common strategy that attackers will use. So it seems weird to patch it in one product for it to get patch diffed and then leveraged against other products before you fix it for those. Generally I would think you would want to like wait and patch it after investigating that. And then also just that turnaround time. I must say, like, especially in the IoT space, over all the years of doing the podcast, I do not remember ever seeing a bug that was reported and a patch was shipped within like a week. I don't really think I've seen that happen with like IoT type devices. And in the past, like Wyze has been criticized for leaving patches for too long, which is sort of a discussion point in this thread. Like, it's like, oh, they wait too long and people get mad. They patch it super quick and people get mad. And that's leaving a lot of the nuance at the door, I think. But yeah,
I
that's
mean, there
Wise's
is
claim on it.
nuance, but there's a clear motivation of Pwn2Own being they don't want to have to spend, because they waited to patch it on the one that they know absolutely is vulnerable. Because of that, it's like if they wait to patch it, they know that's going to cost them like an extra, I don't know, $20,000. I'm not aware off the top of my head what the award or prize would have been for that, but they're definitely like there is that incentive to do it, and I don't blame a company for doing that. Obviously, we'd recommend patching everything all at once. That way, there isn't that kind of patch gap in a sense. But with that motivation, like I can't blame them for pushing it out on the one in particular. And then if they waited forever to patch the other things, as they very well may have, that sucks. But that's what IoT companies seem to do.
Yeah. So I do want to say, like, I'm covering what Wise has said and my like speculations on it. Obviously, we don't know really what happened here. They didn't put out like the report publicly or anything. We just have like this screenshot which barely has anything in it, and their take and Wasty's take. Um, we're kind of just speculating on the timing. Like the timing is weird. I guess that's the only thing you could say that's factual about it. Um, but yeah, so that sparked a bit of a thing. I do want to say that I sympathize with Blasty because it really sucks, working on an exploit chain and then having it killed at the last minute like that, especially if you've already booked, flight and hotel and all that kind of stuff. Um, that
That's the
that
risk
really
of
sucks.
Photon. And we've
Yeah,
talked about so many times, like when you hold off on reporting the vulnerability for that larger reward that you get at Pwn, because generally speaking, Pwn is going to pay better than just
the regular
whatever their
ZDI
bounty is.
pipeline.
Well,
Yeah,
yeah, and even going through ZDI, I was thinking just going right through Wyze, but yeah, even just going right through ZDI because they have kind of the buy-in from the companies that they call their sponsors, like because they have that buy-in, it's going to pay more, but you have a greater risk because you're holding on to it for so long. Like
yeah.
it's part of the game, honestly. Like in my
So that's
mind.
exactly what I was going to lead into. I sympathize, but it is part of the game. Sorry, were you going to say something else there?
No, I was basically what I say. In my mind, it's part of the game. Like that's yeah.
Yeah.
I was basically agreeing with you.
So I think maybe like dropping the repo and being antagonistic, like right in the README, probably wasn't the greatest idea. Because I think that's part of what kicked it all off, right? It wasn't just that he disclosed the bug or the exploit, but the README had explicitly tried to make it a statement. Like I'm putting this out because you guys seem to like screw me over here. So it's that's probably not the greatest idea, but the overreaction on the defender side, saying that this is like some major issue is pretty insane, especially because Wyze actually downplays the issue in their forum thread. Um, sorry, let me just make sure. Okay, sorry, it wasn't Wyze. It was somebody else that had. It was a forum maven, so the first reply, because they'd said you would basically need access on the local network in order to pull this off, which is a high level of access, which is is fair. Um, but then if that's the case, then why are they making such a big deal out of out of the report going public for the other devices? So it's kind of a weird situation. But part of why I wanted to bring it up on the podcast is Live Overflow had made a point, and I meant to find this tweet before I started, but I'd forgotten to, so maybe I'll try to search it up here now. But Live Overflow had made a point that this is basically a perfect uh, case study or demonstration of where full disclosure is very useful. Because if there had been like the report was disclosed, you could see some of the back and forth there and get some insight into the process. I think a lot of the bitterness could have been eliminated here. Um, or at least there would have been less speculation of what had happened. So I thought that was a pretty cool point. And we don't talk about responsible disclosure too much on the podcast because it's kind of a tired out subject. We talked about it in like the early days, but it's been a while.
It's been a
But this
while, and I
is like
actually
a
want to
good
push
point
back
on
on the
it.
term responsible disclosure. Um, just because I would prefer to use coordinated disclosure in where a researcher coordinates with third-party vendor, because
I'd said full
responsible
disclosure,
disclose
but yeah.
and he did also mention we haven't talked about responsible disclosure.
Oh, sorry, yeah, that's true.
Um, so I wanted to push back just on that terminology, and that just goes with the history of responsible disclosure. Like it's making an ethical statement or a moral statement about this is the responsible way to do it. And responsible, as was defined in years past, is like giving all the power over to the vendor. They get to decide when it goes out versus giving the research some authority to say, like, no, you're taking too long or something, and putting it out there and having that threat. Because I think that threat of full disclosure needs to exist for a lot of these companies to actually take action. Otherwise, they just sit forever. Like we've seen companies sitting on vulnerabilities for like a year plus because with responsible disclosure and the right way to do it, um, basically gives them all the authority and power. Whereas coordinated disclosure has at least a little bit more back and forth, and both sides can make the call. It's kind of unrelated to this, but it is a soapbox I want to get on for a moment.
I mean, it's a fair thing to bring up because one of the other points that was raised by, I believe it was Blasty and maybe some other researchers on Twitter, they were talking about like the paying for silence thing that is somewhat common in responsible disclosure type cases, where it's like you'll report it to the vendor will be like, okay, cool, pay you out. However much it is, doesn't really matter, and then they'll just never want the report to go public. And maybe they don't even bother fixing it, or they take forever to fix it. um there was a bit of discussion around that here. And I think the argument there was like, hey, if you won't even if you're going to try to kill my chain before Pwn before I can even submit it, well then, I'm just going to drop it. Like, I don't have any incentive to uh keep it secret, which is fair. um but yeah, I mean, there's been some interesting discussion raised about it here, but I that's the main point I wanted to end on, is that I think this is a strong indicator of like why there should be more openness from the vendor and researchers on these reports, because a lot of the hostilities and stuff that's happened here were from speculation and trying to guess what the other side was thinking or intending, whereas when you have like an actual report and transparency there, that's eliminated, right? So I think this is a good demonstration of that. Is there anything else you wanted to say on it, Z, or do you want to move on?
Ultimately, I will just say kind of where I come down. Like, I don't think full disclosure so early was a good idea. Obviously, it got the result that Blasty wanted out of it. I don't like it without at least some back and forth, but I kind of get the desire to just put it out there. Like I said, they kind of screwed over the Pwn and just kind of returning the favor in a sense. I get it. I don't agree with it, but I get it. Um, are you still there, Spectre? Sounds like might have lost Spectre on this one. I'm not too sure what's going on this side. That said, I will just go ahead and carry on then, assuming we're more or less done on that topic. Although, yeah, he just disconnected from our voice chat too, so I assume he'll join back in a few moments. So, jumping on with the next topic, which is out of Salt Labs. They recently put out a post here, OAuth, that's OH-auth, and abusing OAuth to take over millions of accounts. They end up talking about kind of the OAuth issue that was on Grammarly video, and I think this was an Indonesian name that I'm not even going to try and pronounce here, but on 3 websites that are apparently very well used. The last one is like some marketplace comment. I believe it was in uh yeah, in Indonesia with 150 million used. So I may not be familiar with them, but it's definitely widely used, heavily used. A lot of people being impacted by this. All 3 of these issues are fundamentally the same issue, and it's something to think about when you are testing OAuth. Specifically, it occurs when you're using the implicit grant flow. So that is where, it's meant to be used on websites where you don't have like single page web applications, where you don't have like a back end or a real good way to store a secret that you don't want the client to use. So all you get out of it when you're doing the OAuth flow is you get an access token that is relatively short lived, and you don't get like the refresh token that you would get when you do like the whole auth code flow. Um, and so basically, their tag going through the normal OAuth flow, they realized is that a lot of these applications or a lot of OAuth implementations aren't validating that the token, the access code, or sorry, the access token that they actually get back or think they're getting back from like Facebook or whatever application, they don't validate that that token was actually issued to their own client ID, which usually all of these applications will have like a token endpoint or some sort of endpoint that you can access just to find out information about the token that you're currently using. Usually lists things like scope, and it'll list the application that's issued to. So effectively what could happen is some sort of privileged attacker who maybe has their own website, people have logged into it using one of these OAuth identity providers. They can capture the access tokens from there, and then on another application, take that access token and use it. So that does require a somewhat privileged attacker, although and I guess when you use it on this other website, if that other website then uses it to validate, like, oh, this account belongs to whatever email, so this is their account on our website, that's where you get the account takeover by using somebody else's access token, legitimate access token, but issued to a different client or a different application. They'll reuse that on the vulnerable application. It doesn't validate that was issued to them. They start using this token on that application. And then when they check, like, oh, who does this belong to, associate with an account, um, they associate with the account and just give whoever has access to that token access to the account. So you're able to kind of pivot. And that, I think, is an important aspect. While it is a bit to ask that an attacker could generate a website that a lot of people are going to go sign up on, definitely doable. I mean, people have been doing that sort of thing for many years. It would also be a way of just leveraging access tokens that you leak from another attack and going, okay, I've leaked all these tokens here. Now I can leverage this one breach to breach a bunch of accounts on some completely different website, or likely many other websites. And so for the first two cases here, with video and the Indonesian website, those two were just straightforward. It was using that implicit grant flow. And Grammarly was a little bit different. Grammarly was trying to use the complete authorization token flow, which, I mean, fair enough. They had something that seemed a little bit more secure. So with the auth code flow, what happens is, instead of getting the access token right back, when Facebook or whatever OAuth identity provider redirects back to the application, it'll send in a code, and then that server or that application should take that code and it'll exchange it again on the back end. And when it does that exchange, it includes the client ID and client secret. So it can only exchange the code if it was issued to it. Basically, the issue that they're abusing in the implicit flow is impossible if you're using the code flow, because the code is never going, or the code will always be verified. They'll always make sure that this is the right client ID, so you can't really do it there. Although what they found was that the redirect handler, so the web page that actually gets the redirect back, when that comes in, it checks what the URL parameters were. So if it sees an access token as one of the URL parameters that it got back, it would just go ahead and pretend as though it got that through the implicit grant flow, and it won't do the rest of it. So they were basically just able to switch it into using another flow. And that was particular with Grammarly. And that's something interesting to kind of keep in mind. That feels like you can end up in some weird state situations if you have something that tries to implement a handler, or the same handler, for an implicit flow versus the auth code flow, and probably PKC and all of that too. If you have these different states and it's trying to handle that all in one, definitely kind of a state area that you might be able to mess something up, although I can't really imagine exactly what you'd be able to do there. Just, I don't know, feels a little bit sketchy to me. Obviously, in this case, they were able to trick it into using the flow that was vulnerable to this. All of their examples are just they create this fake yourtimeplanner.com is a fake website people might sign up for using the OAuth tokens, or using like a login with sort of thing, and that's how they capture the tokens. Though I also think the idea of leaking tokens from one website and pivoting that attack into another would be viable too. Ultimately, does require the legitimate access token, which is a big ask, but I do think it's viable for an attacker. You would have, if you wanted to test for this, ideally you're going to use your own token from somewhere else, and that could be a fair way of doing it. I'm not going to recommend anybody doing a bug bounty actually steal somebody's tokens to test this, but easy enough to also just get a legitimate token for your own account and give it a shot there. I thought it was an interesting series of attacks. Also, just it's something I haven't really thought about. Like, I've had the thought of like using these access tokens, but not what can you do if another website, like if you were to trick another application to it. So I thought that was an interesting kind of trick or perspective to take on these OAuth style issues. And I believe in chat somebody mentioned, yeah, root them all. I like how OAuth is supposed to make things more secure. Yeah, we seem to get some random integration problem every other episode. Yeah, that's the thing. OAuth is, I feel like it is easier to understand than like SAML. Because SAML was a real pain to work with. Can do a lot more, has a ton of functionality, and just a ton of issues happen there. OAuth in concept is simpler, but this also like using OAuth as like the identity provider. So there is open access ID or open I is it OpenID Connect or something? OIDC is the acronym for it. I forget exactly what it stands for, I guess, but there is kind of that which adds on to OAuth, which adds a token instead of going for like a code or something. You get a token which represents the identity of the user. And in theory, that's better. And in some of the discussions about this, I saw people saying, well, this is why you should use OIDC, but you could have Rudimal mentions OpenID Connect. Yes, that is what it was. Um, I saw people saying, well, OAuth is for authorization, whereas OIDC is identity. So if they just use OIDC, it would have been okay. And I actually want to disagree with that idea. Even OIDC, it's just the issue changes. Um, Instead of needing to validate that it was issued to the right client ID through like another request, you would have to take this and validate that it was issued to the right audience or AUD parameter in the JWT in the token that you get back. You still have to do that validation. You could still mess it up in exactly the same way. So OpenID Connect doesn't actually fix it, but I did see a number of people mentioning that, and I do feel like remembering to check the audience in a JWT is going to be a lot more obvious or straightforward for somebody doing the development, but not impossible for them to forget. I would like to think that it would be easier for them to catch such an issue, but it does look like we've got Spectre back, so I'm not sure if you've got anything to say or anything to add on here.
To be honest, I'm not even sure fully what you talked about. I came in the middle, so yeah, my power went out. That was awesome. It flickered, like it went out, and then I heard a thunder crack, and I was like, okay, well, that's excellent. Um,
Good
I
timing.
promise. Yeah, I promise that was not like some elaborately engineered thing to for like supporting the recording of the podcast.
Yeah,
And it's funny
that's
too because I'd said to you before we started, I was like, I think I'm going to reboot my PC after the podcast. Well, I don't need to do that anymore. So,
that was actually what I thought ended up happening. You just need to reboot. Anyway, I was just wrapping up on the OAuth issue from Salt Security.
okay. Yeah, it was a pretty cool post. It's an issue we've seen before, definitely, with not checking the app ID.
I'm not sure
I
if we
feel like
have
we've
seen
seen
this
it
one
with.
before, actually. I thought this was kind of novel and like an interesting perspective on it where you're reusing an app ID that was issued to another application. Maybe we have. I don't recall talking about this particular issue. I think we've seen some other validation issues, but being able to reuse a valid access token from another application, I thought was a little bit novel to me.
I believe there were some Yusuf Samuda posts on reusing Facebook tokens, sort in a sort of similar way, but I might be misremembering.
Yeah, I think I remember the post that you're talking about. I don't quite think it was done in this way though. I think that was more about uh like because that was more about capturing through the redirect and getting it to redirect to him when it shouldn't have still. But it was that he was capturing the like Instagram or whatever the first party one of the first party token sources. I think, or at least that's the one that comes to mind when you mention Yusuf on this. Like, I'm reminded of that one, which is a little bit different than this attack.
The part of this post I liked the most was the Grammarly specific attack. Now, I'm guessing you had covered that with the code exchange thing.
I did. I covered it more or less briefly. I kind of treat this as all three are more or less the same attack, although in that case with Grammarly, they were able to just brute force the parameters and basically get it to fall back into using the implicit flow or think it used the implicit flow instead of.
Yeah, I thought
Uh,
that aspect of it was pretty cool. Because those cases are always fun where it's like it doesn't look like it's exploitable and a lot of people probably would move on, but then you're able to find out like, oh, there's this alternate route that you can force by providing the access token directly. So I
Yeah,
like
I
that
do
part of it.
wonder if there is like a legitimate case where that's being used. Like sometimes it just, in some situation, it is just using that implicit flow, or if it's case that maybe they upgraded or changed their path and just kind of left in the support for both for a little bit of time and never removed that. I do kind of wonder what led to that behavior. It is interesting behavior though.
Yeah, it's questionable, and I'm kind of curious on it too, but it's impossible to know from the outside. So yeah, I don't really have any more thoughts on that. So I guess we can move into the next topic, which is the healthcare polyglot. And see, I'll let you get into this one as well.
Yeah, so this is CV 2023 33466, which nobody's going to remember after this. Exploiting healthcare servers with polyglot files. And this is fun, just because, well, as the title kind of introduces, we're dealing with a polyglot file that they were able to abuse to get RCE. Ultimately, this does feel like a pretty weak, weakly secured system, but I think the idea is that this generally isn't supposed to be on the internet, though they do talk about later how this is. But this is with Orthanic and their DICOM image server system, which is completely open source, which I thought was a little bit neat. We actually have the patch for this bug, and they were treating this as like an end day development. They had this patch, they knew about the CV, they just didn't have an exploit for it, so they set about trying to exploit it on their engagement. So coming in on the actual issue, basically they had two REST APIs um, that were authenticated, so this had to be an authenticated user. Although I'm presuming in their case they either found the credentials or it was using default credentials, and they do talk about there being several dozen servers connected to the internet that are currently using, or currently at the time of writing, using default credentials. So, yeah, so it is possible to get onto these with the default credentials and hit that authenticated endpoint. So, there are two endpoints. One of them would allow you to import a DICOM, and all DICOM is some sort of within like medical imaging systems, it's some sort of file supporting that. I've never like worked with it. I can't like discuss exactly what it looks like, but it is just some file that they use or file format that is used in medical imaging. Um, so it would allow you to import a DICOM, and there was one that would allow you to export a DICOM anywhere on the file system, and that included like as a not a dot di or DCIM or DICOM. I'm not sure which you use, but it didn't require you even had the right file extension. You could just overwrite any file using this. So that gives you potentially a relatively powerful just import a file and then export it to any location. It gives you that sort of file overwrite anywhere on the operating system or anywhere on the server as like your core primitive. But the problem was that in importing the DICOM, it would, of course, be reading information out of the DICOM. It would need to parse it, get whatever information's attached to it, and get all of that. So they'd have to go and take the DICOM file, parse it. So you couldn't just use an arbitrary file. As the title kind of implies, they were able to use DICOM as a polyglot file. So they could have the DICOM be parsed as a DICOM and as something else. And that's because the DICOM file, as they dug into the spec, had this header section that had both a preamble and a prefix. The prefix is more or less what you expect of a header. It starts with like the magic bytes DICM as just four magic bytes. It really marks the start of the DICOM file, along with whatever other metadata there. And the preamble, interestingly, was just this 128 byte region, fixed size, that can contain anything that any application that's generating the DICOM or working with them can just include whatever data they want in it. So it made it very easy to have a small bit that could be used as a uh, used for a polyglot sort of attack, because basically 128 bytes, that is free for you to do whatever you want, and any bytes that you're not using, I think it wanted like a an Yeah, I tried searching for the letter H in here to find one thing, but I think it wanted like literally just the H character in there, something like that for any of the leftover bytes. They end up just using some null bytes after in their example here, but
I think it was a space, wasn't it?
the hex 20. I could have sworn it was like it doesn't matter honestly.
Oh, okay.
Maybe it was a
Yeah, fair
space.
enough.
I thought it was
Yeah, it's a
something
space. It's yeah,
else.
hex 20. Yeah.
Okay, maybe I'm misremembering things, something else. Either way, doesn't matter. You have this 128 uh byte section that could contain any piece of information, which means they could include the attack they went for with this was to create a JSON configuration which is used by the application. So basically overwriting the application's configuration file with their own custom configuration. And as I kind of mentioned about this being a little bit insecure by default or feeling like a very weakly secured API, in the configuration, it has execute Lua enabled, and by default it is disabled. And that would enable, when you turn that to true, it would enable an endpoint, uh, that tools execute dash script that would take in Lua and execute Lua. So I don't know why like a medical imaging server needs that sort of endpoint in their API. There might be some use for it. Like I don't know what they're doing. I have no familiarity with this realm, but it feels like a really weird endpoint to have. But they were able to basically just create this execute Lua enabled and remote access allow true as like the two fields in their config. Have that, write it out too. In their case, they had a bit of access to figure out where it was, but you might have to guess where the configuration is stored by default and then restart the server because they didn't have a way of disclosing the um where the configuration was being read from. They can just test different common paths. They use the example of Etsy orthonic.json and temp orthonic.json. So both are fair targets. You might have to play around with that a little bit to figure out where, but ultimately get the server restart, which again had a endpoint to do it. And do that. The most interesting here, I think, is just seeing yet another kind of polyglot file, and a lot of files that just make it easy to inject arbitrary data into them. Like it's always, I get that it happens and a ton of applications do this, but not necessarily with the preamble thing, but just have places where arbitrary data could exist. It's just always a little bit surprising how permissive the formats are of arbitrary data being in them.
Yeah, I was gonna say it's very interesting because I don't think I've seen like any other formats that work like this, where your arbitrary content can be at the top. Like almost always when I look at files, like the magic and all that stuff is going to be right at the top of the file, and then maybe there's some auxiliary space after the header.
It doesn't
But having it
zip.
before the header is very like strange and I guess nice from an attacking perspective.
I feel like a zip or maybe 7-zip or not 7-zip, tar or something that does this where you could have like arbitrary data ahead of it. I might be wrong about the file format here, so I'm saying zip and stuff or one of those archive ones. I might be mistaken, but I believe like the way that would work is it would basically just look for its magic number to eventually exist within the file, like something that marks its header, and then everything else before it's just ignored. I feel like it was Zip that was really permissive in that, but I'm not entirely sure. Maybe it was Zip that actually put the header at the bottom of the file. That might have been it too. I because I have seen a couple. I have at the very least seen some cases where like the header is at the bottom, so it's more like a footer, I guess. And things like that, which then allow a bunch of arbitrary data to exist because it doesn't need to match up, or like you can turn that into something that could contain arbitrary data. But yeah, oh no, I've at least seen similar things, but specifically 128 bytes is not something I've seen, or where it's that
That's a
fixed
nice bit
size
of
block.
leeway. Yeah. But yeah, and the other thing, like you'd mentioned, like exposing an ability, like it's off by default, but like even having the capability to run Lua of all things was pretty interesting. I was like, I don't think I've really seen that in a web server before. I mean, I guess it does make sense as a nice plugin language, but uh, yeah, a very nice target to go for as an attacker if you can get configuration hijack in this way. So yeah, there's some really cool aspects of this attack that I liked.
Yeah, and Rudimo mentions, yeah, Zip had them at the bottom for SFX, I think. Yeah, so that might have been what I was thinking of with it being kind of really permissive and what you had ahead of it. And yeah, on the aspect of Lua, like I don't know what they're doing, like the type of people that would be using the server. Maybe it does make sense, and I just don't know. But like from the outside medical imaging viewer, I can't imagine why they need Lua. It feels almost like a development function that was just left in and disabled by
That's what I would
default.
edge towards as well. Yeah.
Who
And yeah,
knows?
fair enough
Maybe
with like zip files. I don't really do a ton of file format parsing, to be fair. So yeah, uh,
I'm pretty sure I
could just
know
be a
that
lack of
because of a CTF. I'm sure that's something
of
that's been
course.
used in a CTF.
DTFs are best for finding quirks like that, so that would make sense. All right, so we'll get into our last topic here, which is an asset note, and it's called Citrix Bleed, which is an information disclosure in Citrix NetScaler, which is used for like load balancing and firewalling and such. There was a CVE published, and asset note basically decided to patch diff it and analyze what the vulnerability was. And this is a bit of a rare topic on the bounty episode, in that the underlying issue is sort of a binary issue. But we thought we'd cover it today as it impacts the web side, and it's not too crazy of an issue, even if you're not, well versed in memory corruption. So they ended up looking at this NSPPE binary, which is the packet processing engine, and discovered that out of the changes, two functions stood out as interesting, being this NS AAA OAuth send OpenID config and OAuth RP send OpenID config. And the relevant code here is they would use snprintf, which is, it'll print into a buffer with a maximum size, and they would use that to create a string of the JSON configuration, plugging in various variables up to a maximum of hex 20,000 bytes to the final string, and then they would send the response using the return value of snprintf for the length. The problem is the value snprintf returns isn't the truncated size or the size that it actually wrote to the buffer. It's the size that it would have written, regardless of whether or not that write was terminated early. So just, I guess, misunderstanding the return value of snprintf, and it's a fair mistake to make because you would expect it to return what it wrote, not what it could have wrote.
Yeah, and like
Um,
generally with all these printf functions, they do return like, when you call printf, it returns how many bytes it wrote. When you call sprintf, it returns how many bytes it wrote. When you call fprintf, it returns how many bytes it wrote. But snprintf has to be special, in part because
yeah,
snprintf actually takes in this value that tells it how many bytes it can write at most. The second parameter of that is like the limit of how many bytes to write. So it kind of has that, and so you should know from the output that, oh, it's bigger than this value, therefore it wrote too much, or like didn't actually write all of it. And that behavior of snprintf is used to determine, like, you can give it 0 and just figure out how big a string would have been. And I do also just want to quickly mention that what it's writing out here are the OpenID configurations. So that's if you want to support kind of dynamically adding an OpenID provider or like an OAuth provider to your system, you can reference the OpenID configuration page to get all of like the authorization endpoints, who the issuer is going to be. Various endpoints are in there. Well, like it has the entire URL and like methods that it supports and things. So that's what it's trying to do here, and because it doesn't know the URL, or I guess you're probably about to get into what it's writing, or did he mention that already? That's writing the host name in there.
yeah. So I haven't gotten to that yet.
Okay.
So like, yeah, a lot of those variables that it's using in the printf are not necessarily controlled. Though one of them is. So initially they didn't think this bug would be reachable from unprivileged because the variable you can control in that string construction was the host name. Which they were like, okay, this should only be configurable by an admin. It turned out, though, after they dug into it, that string actually came from the host header of the HTTP request. So by simply sending a GET request to the OpenID config endpoint with a large host header, you could trigger that vulnerability, get the server to try to send more data than it had, from using that, erroneous snprintf return value, and leak data from the server. After enough like iteration, their ultimate leak target here was a session token. You could leak a session token and use that for a hijack. So yeah, I mean, it's kind of cool. It is a binary level issue that's impacting on the web side, but that's problem of ambiguous return values in the form of snprintf is not exclusive to like binary memory corruption. It's just how it happened here, and yeah, pretty cool to see information disclosure through like HTTP requests like that.
Yeah, I
Um,
mean the name here is kind of a tie back. Citrix Bleed kind of ties back with the old Heartbleed issue where
yeah,
you would give a too large a size, and it would output just adjacent memory, exactly like what's going on here. In this case, you give it too large of a string so that it generates too large of a string, and when it's sending it out, it's like, oh, it's this big, so let's just use that value again. That doesn't actually reflect what it wrote and shows it out. I do want to mention, like, if you're hunting for this and you're wondering like how do people know, like how did they know that they actually got an auth token back, or how do you know that's what you got? You basically don't. um in the response to these, you'll start seeing, like, usually you'll just see some sort of garbage data, things that just don't make sense as part of the response, and it's kind of up to you to figure out what that is so they can say like, oh, this looks like a access token or something, and then that, when they try it, it's like that worked. So if you're testing for something like this, so they're using a long string, bad size information, noticing just the garbage data, I think, would probably be the biggest thing to notice. Refresh a bunch of times, see what else comes up, and other than that, it's a lot of guesswork. See, oh, what is this? Sometimes it is actually labeled if it's printing out like a JSON or something, but most of the time you end up with these like data structures that just have the memory packed in there, and you have to figure out what it all means. Like, there isn't any real trick to that. It's just, what does it look like?
yeah, I don't want to go into it too much here, but do they mention whether or not that buffer is a stack or a heap buffer? I don't think they do, right? That would be
um
an interesting nuance, right? Because if it's in the stack, then the data that you're leaking would be fairly consistent and predictable. Whereas if it's in the heap, then you might have to do some, uh,
I mean, I kind of
heap grooming or
assumed
whatever.
that this was in the heap, just because
That's
of the
my assumption as
size.
well.
Like 20,000 bytes is a pretty
That's
massive
yeah.
size for a stack. But
You know
yeah, it
what?
doesn't
That's
look
fair.
like they
That's
say
almost
it.
certainly not in the stack. Yeah. And that would also explain why they say that they had to do a few requests, and it was implied that it wasn't a super consistent leak. So yeah, I think heap is probably a reasonable assumption. But yeah, I won't go into that too much here. But yeah, so it's a fun topic, and it's not every day you see like a information disclosure over requests like this. Um, Usually information disclosure is like the hardest thing when you're hitting remote targets. So and it's cool too, because initially when you look at this, if you like don't read down too far, you're like, oh, it looks like it's going to be a buffer overflow, but it's not. It's almost abusing the fact that they were trying to protect from a buffer overflow, but just not being aware of all the implications of the API they were using. So yeah.
Yeah, and that is kind of one of the things that can make or let this kind of slip through. A lot of cases, like, you're writing test cases around this. I have no idea if Citrix was writing test cases. But you write test cases around this. You think like, okay, let's make sure it fails to write around with the sprintf, or uh, you make sure it returns the right value when you give something smaller, but something like massive anyhow, but like not quite enough. It just feels like the sort of edge case that's easy to miss unless you're aware of exactly how snprintf works. And then you write your tests around that. But a lot of developers just see it as sprintf plus n, like plus being able to set that limit.
Yeah, which is intuitive. Like it makes sense that you would think of it that way.
Yeah.
That's certainly how I use it, like 99% of the time. So, all right, so that's all the topics we have for today. We do have some shout outs. First up, I have this post, hacking a silent disco from not Matthias. Nothing super crazy here. There's not even really a vulnerability. It's mostly about reverse engineering this digital jukebox site and doing some vote manipulation with anonymous voting to always get their songs played. So there's nothing technically, you know, deep or anything in there, but it's kind of a fun story, taking advantage of this DJ app and being able to play whatever you want. So it might be a fun read to some of you out there. It is more on the website. It goes into the requests and trying to dig into uh, writing like an application or a bot to vote on the song that they want. So yeah, it's a
Yeah,
bit of a fun post, but we're not going to cover it here because there's not really any bugs or anything like that in there.
it's a bit of like network protocol. In this case, actually, WebSocket protocol, reverse engineering.
Yeah,
Although
and
they
then
did
Z.
kind of luck
Oh,
out a little bit having I think it was an iOS thing that gave like the names for a bunch of one letter things, but yeah, it's just you can learn something about doing the network reversing a bit. And then
for
yeah,
sure.
I had the other shout out here, which was a actually it came from a small CTF challenge. I'm kind of kicking myself because I saw this on Twitter and then I went to do other things and I completely forgot about because I'm not actively on Twitter to see discussion about it. Looked like it would have been a fun challenge to at least try here. I'm really just leaving this as more of a shout out because it feels a little bit unlikely to me and it does require somebody able to copy and paste. Like it requires that level of user interaction, but it does look like a pretty fun challenge to give a try to. Um, and that's just trying to get. They have a very simple attack page. I'm going to open the source up here, and it's basically with this code here, which all it really does of interest is um, includes Angular min.js and nothing else really stands out. Content editable div, but it basically goes into trying to exploit that content editable and doing something there. I'll leave exactly how that works if you want to give it a read. But yeah, it felt a little bit too CTFy for me to kind of include as a main topic, but an interesting read nonetheless, given some of the things that have to go right for this one.
All right. So, as always, thanks goes out to everyone who tuned in. Previous episodes will be found on YouTube, Spotify, Apple Podcasts, and more links on Anchor. Our Discord and Twitter links are down below or in the chat. Once again, we are thinking of moving to like a recorded format, so feel free to leave thoughts about that in the Discord as well, because we're looking for some feedback before we do that. And we'll be back for tomorrow's binary episode at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.